Hello, and welcome back to another episode of Low Spec Labs. Before we get started, I would like to stop for a few moments, and I would like to thank you. Thank you for visiting the channel, watching my content. Thank you for commenting, and thank you for subscribing. I would like to do more than just say thank you. I'd also like to give back to this community. And in order to give back, I'm doing a giveaway. If you're in the Jacksonville, Florida area, and you would like to win a free mini bike, please go to giveaway.lowspeclabs.org and fill out the form. Once you've done that, you'll get an entry for you to win a free mini bike. If you subscribe to my YouTube channel, that's one entry. If you leave a comment, that is another entry. If you subscribe to my TikTok, that is a third entry. So you get up to 3 entries to win. So I wish you the best of luck. This chapter, which is chapter 19 in Sander Van Voigt's RHCSA book, is about Linux scripting. More specifically, bash scripting, because there are a number of different shells. So we're going to talk about scripts. We've got to ask some basic questions first. Why should you use a script? Have you ever had to do a task, and that task is going to need to be repeated on multiple computers again and again? Have you ever had to do a task on one computer, but that task has to be done every day for maintenance purposes? Those are both perfect times to use a script. Spend a couple extra hours figuring out how to get the script going, and then you get to save lots of work, because now you can get those tasks completed in a few seconds at the press of a button versus manually going through and doing them again and again. Scripts are very useful and powerful. Let's talk about bash scripting and how to set one of those up. So how do you actually write a bash script? Let's find out by trying to write one. To our right or to our bottom, depending on how you're viewing this, we have our terminal pulled up. So from terminal, writing a bash script is as easy as doing something like nano, which is our editor, and then we're going to call this hello world.sh. Every bash script is going to begin the exact same. How is it going to begin? Well, by defining where we want to find our bash. We do #shebang /bin/bash. And that's how the system is going to know that is a bash script. After that, we can do something simple like echo hello world, and then we save and exit. Then we have to make our script executable. To do that, we do change mod, and we want to give this user permissions. Now, when we list the file, you'll see we have hello world.sh, and to run it, we simply point to that file. And as you can see, we have hello world, so I added an extra W there. Let's talk about what we just did there. First thing we did was we started with nano hello world. Basically, we used the nano tool to create an empty file called hello world. Let's see what we put in that file. Let's talk about the shebang. The shebang basically defines the subshell we'll be using. So when the Linux operating system opens the file, because the shebang is there, it's telling the operating system, hey, this is a script, and then we're pointing it to the shell or language we're going to be using that script with. So if we were to change that shebang to something like Python 3, bin/Python 3, we'd be using Python 3 as our scripting language. If we were to change the sh, we'd be using the old shell that's baked into Linux. If we were to change it to zsh, we'd be using zsh shell. Lots of different ways we can define shells and write scripting languages. For Red Hat purposes, the one you need to know is bash, the born again shell. Bash is pretty useful, actually. It's a very powerful shell unless you do a lot on systems. I am a mere beginner in it, but you got to start somewhere. In another 10 or 20 years, I'll maybe be proficient. Maybe you might even be able to call me an expert. We shall see. Scripts are useful. You could view scripts as recipes, and the recipes give you finished meals, or rather desired states that you want your system in. Let's look at that script again. So this is a very simple script. We're simply telling the system this is a bash script, and then we're telling the system to echo hello world. Very useful. So our hello world script is a very simple script, but it's not very useful. Where scripts become useful is with arguments. What is an argument? Well, arguments are variable or inputs you can pass into and out of a script. We can talk about this all day, but it's easier if I just show you. So let's practice. If we were to do nano and reopen that script again, we could do something as simple as pass an argument into this, and we could do something like echo, the first argument is, and then just the number 1. So we passed an argument through. How do we actually use that? So let's do hello world, and then we're going to want to pass an argument after we call the script. So in this case, our argument is, let's do Lisa. As you can see, we now have hello world. The first argument is Lisa. If we were to remove Lisa and run that script, you'll see we get nothing because we didn't pass anything through that. If we were to pass in test, you can see we get test as our first argument. How do you pass through multiple arguments? Let's practice it. Let's walk through a simple example of passing through multiple arguments, and then we will walk through an advanced example. So let's go back up, do another nano hello world, and we're to do echo. The second arg is oh, this is fun stuff, boys. Feeling real hacker man with this one. And then we do the third arg is, and there we go. Now, if we were to run hello world test arg1, arg2, we have 3 things here, where earlier we had just 1. Now let's run that again, and as you can see, all our arguments pulled up. This is cool, but it's not very flexible. Basically, we have a hard-coded number of arguments, and if we were to drop 1, our script still runs, but you can see we have 2 empty options inside of here, so we basically have to remember all the different variables we want to pass into the script. It's not very flexible. You ever tried a deadlift without flexing, boys? Ooh, you're gonna hurt yourself. Don't do that. So how do we make our script flexible? Well, to do that, we need for loops. So what is a for loop? A for loop is a block of code that runs until a condition is met. That seems pretty simple, and it is pretty simple. So let's practice it. Come on, boys. This will be fun. Let's create a new script. So we'll call this new hello world. And then of course we gotta let the system know that this is a bash script. So we'll do bin bash. And then from there we define our for loop. First we want to echo how many arguments we entered. So we do echo, you have entered args. Alright. So let's go through what we just did there. We did echo, you have entered args. So the $pound symbol basically counts the number of arguments we put in. So if we were to run this script, first let's make it executable. Every script you write must be made at least executable by the user who wrote the script. So from there, we can do new world, and then we want to pass in 3 arguments. So we'll call this arg1, arg2, arg3. And as you can see, even though we entered 3 different values, it showed us the number 3 instead of arg1, arg2, and arg3. That is because the $hash symbol basically counts the number of arguments we passed into the script. Now, how do we get those arguments out of the script? Well, we're going to use a for loop for that. With for loops, as long as the conditional statement is true, the loop will be executed. So what does that mean exactly? Let's practice. Sometimes it's easier to explain a concept as you walk through it than it is to actually talk about it. Let's do hello world.sh. Let's try this for loop with our new hello world script. So let's do new hello world, and then let's try that loop again. Let's do for, and then for this for loop, we want to call our arguments. And notice we used a different symbol this time. We used $@. So what that does is it calls the current argument. And you'll see why we're calling the current argument in just a moment. So first we write the for loop. We then tell it to do. So for loops execute if the condition is true. So we do if, we do echo I. And so basically it's gonna echo whatever we enter for the first value. And then we do done. And then we have to tell the script that the code is completed. So to do that, we do exit 0. Now, let's go ahead and close this script. So we ran ahead and ran hello world.sh, and you'll see we now have I iterated again and again. We have I. Look at that. So let's go over those script special characters again. Remember, the # exclamation mark starts your script. The $pound counts the number of arguments in your script. And the $@ keeps track of the arguments you pass into your script. What are variables? A variable is a reference to a specific location in memory that holds some type of data. So variables can hold numbers, strings, commands, whatever you want it to hold, basically. It's an arbitrary value store for data. So how do you use a variable in the script? Well, first you define the variable, then you pass the information along to it. Let's go ahead and try walking through that. So how do we define a variable? Well, I've already written a script for this. Let's go ahead and echo it out. So we can do cat./hello world. And in our script, you'll notice we have three things. We have the shebang defining the bash script. We have var1 equals hello world. And then we're echoing var1. Let's open that up. There we go. So because we've defined echo as var1, if we wanted to make changes, we could do hello world, goodbye world. And then if we were to run this script again, you see the value changes. And if we were to go back in and run this script one more time. So what we did was we created a variable and we can assign whatever value we want to that variable. This is useful because now we can arbitrarily change those values and modify our script. What are conditional loops? Well, conditional loops are stuff like if loops, for loops, if then else loops, while loops. Basically, they're blocks of code that run until various conditions are met. We've already gone through if loops. Let's talk about for. We've already gone through for loops. Let's talk about some of the other ones. So when should you use stuff like if then else? Well, that's if you have a block of code you want to use if and only if a condition is true. So this is an example of an if then else loop. And the if then else loop basically runs while a condition is true. So first the program starts. We then have the second step after we start the program, which is the condition or evaluating the condition we want to see if it's true. In this case is x greater than 10. And as long as x is greater than 10 or whatever variable we'll define is true, the block of code will run. And if the condition is false, then it'll stop or a different block of code will run. Let's say the best way to learn is by doing. So let's make a script, an if then else script. We do a nano if then else.sh, and then we define our file. And then of course we start with a shebang, bin bash, we do write control, and then we go from there. After that, we want to define the variable we're going to be comparing it to. So to do that, we define our variable. We're going to call this var1 equals 10. There we go. Our variable is defined. From there, we define our if then else block. The structure for that is if then else phi. And then from there, we can define what we're evaluating. There should be a space on either side of the end of these brackets. And in between, we're gonna evaluate var1 is greater than 5. Then, to test if what we just typed in worked, we're gonna use some echo statements. So with this, we use spaces again. We do 4 spaces, so we do echo var1 is greater than 5. Then close it, and then we do else again with the 4 spaces. We do echo var1 is less than 5. And then of course we make sure we have the right spaces. And there we go. We now have it done. With our script now completed, we have to make it executable. Let's do that real quick. We do a control X, do a quick change mod. You can see I already ran it once before. And then we simply run the script. And as you can see, var1 is greater than 5. So if we were to go back into that script and change var1 to 4, we will get a different result. var1 is less than 5. And that's how you use an if then else statement. Okay, let's continue with for loops. So what is a for loop? So we know the definition of a for loop. In practicality, a for loop could be imagined as an if then else loop that iterates as well. So a for loop runs the code as long as the value we assign it to iterate over is true. In our case, we create a value called x. We make x less than 5. And then looking at our map here, we can kind of break down the logic that's going to happen. As long as x less than 5, that's true. So it runs this echo statement. Then after it runs the echo statement, it adds 1 to the value of x. So for instance, x was 0. By the time the code got to here, x would now be equal to 1. And then it loops back around and looks at the value of x again. And it does that in a circle until x is greater than the value we assigned to it. And then the statement is false and the program ends. Ooh, that was a mouthful. That's a lot of words to say a very simple concept. Basically, we create a loop, and then every time we go through that loop, we add 1 to a counter. That's easier, right? Now let's go ahead and practice actually doing that. So how do we create a for loop in Bash? That's simple. To make it kind of easy, let's do nano for loop.sh. Then of course we have to start with our shebang. Then we put a quick description using a comment. So we're going to call this for loop. So what we want to do is start with our for statement. So we do for I and do and done. We're not quite done yet because we still have to go through and pass the x variable into our echo. Because we're passing a variable through, we're gonna have to do something special. So what we'll do is quote, then we do $, then we do curly brackets, $, and then x. And what the curly brackets does is basically tell the shell that this portion right here is a variable. Now, when we run the for loop, you'll see we get an output of 1, 2, 3, 4, 5. And it goes up to 5 and then stops after 5. What are while loops? Let's talk about them real quick. While loops are used in both programming and scripting. They are data structures that are used to run a block of code until a specific condition is met. Let's walk through the logic of the while loop. First, we have our condition. This is normally something like x is less than 5 or 6. After we have the while loop, we have the body, which is where our code is going to go. And before we finish that, we're going to have a piece of code that updates the while loop. After we're done, we're going to use another bracket to close that block. So once the code is executed, the system then checks the condition again. If the condition is true, it runs the while loop one more time. If the condition is false, it go ahead and runs a piece of code outside of the while loop. All right, so let's go ahead and practice with that while loop. We're going to do a touch while loop.sh, and then we're going to make it executable before we even open it. So we're doing something a little different right now. And then we're going to go into that file and actually start writing the script. Remember, every bash script starts with a shebang, bin, bash. Then we comment our code, and then we can actually start the loop. So let's go ahead and start by defining the condition we're going to be testing with. In our case, we're going to call this num. We're going to set this equal to 10. Then we're going to do our while loop. So to do our while loop, we're going to do while, just like we would do an if loop, brackets, space on either side of the brackets, and then we call our variable again, which is num, and we do num is less than 5. All right, and with that, we've just defined our condition. After that, we then have to put in the logic for the while statement. How do we do that? This is pretty straightforward. It is just simple. It's pretty straightforward. It's as simple as doing do, done, 4 spaces in between, and then we're going to echo number is, and then of course we're going to call our variable num. Okay, and then after that, we iterate the num value again. So we do num equals, and then we're going to pass the variable back through. So we're going to do $2 I repeat, 2 parentheses, then we do number plus 1 with a space between each one, and then we close the parentheses again, right? Now, when we do the while loop, you'll see we get an output of nothing. I see what happened. So I tried to run the script, we got nothing as the output, and after looking at it, I see here that num is already set above that. So what we do is we set num to 0 so that our test is true. We click yes, we run while scripts, and you see it kept running until number was more than 5. So you can use your condition to run code any number of times until you get the result you want. What are until loops? Until loops are a lot like while loops, but one of the main differences between a while loop and an until loop is that until loops are designed to run while the condition is false and only close or stop when the condition is true. So a while loop runs while the condition is true. An until loop runs until the condition is false. So it's the inverse of a while loop. Let's go ahead and work on that until loop. So just like before, we're going to make a file called until loop.sh. We're then going to make that file executable. There we go. Now we can enter that file and start coding or scripting. Shebang /bin/bash to define our terminal. Then after that, we do define condition. So in our case, our condition is going to be called num equals 1. And then we define our until loop. We do until, and then we do num greater than 5. Then we do done. We do echo. So what did we just do? So we defined our condition, which we set to a variable called num, and we set to 1. So this code is going to run as long as num is less than 5. We can then do a quick echo to print out num. So we do echo num is, and then we call the number. And then we have to go back in and once again define num, and then we set it to a variable, right? And then after that we do num plus 1. Looking at our output, you can see here we have our numbers applied. Num is, and then num is 1 through 5. So what are case statements? Let's find out together. To understand case statements, we have to go back and look at our conditional values. As you can see in our conditional values, we have the condition itself, which is what we use to evaluate whether or not to continue with the rest of the program. Imagine case statements as conditional statements with multiple conditions. It might be a little bit easier to explain with an example. Let's walk through it. First, we create our file. So we'll call this touch case.sh, and then we make this executable. There we go. And then we do a quick nano /case.sh. Then we do a shebang bin bash. Then after that, we can actually start the script part. So let's pull this up. First thing we do is define a variable. Then we do fruit, because we're going to be using fruit as our test case. And then we're going to do apple. Then we define our case. And when defining a case, you're going to do case, and then we're going to call that variable in, and then we're going to escape the case. And then from there, we do to, and then we can define the different cases. So for instance, we could do apple as one case, and we're going to use the close exponent as an example. We then do echo apple is quite tasty, and there we go. Then we do banana, and we close the case. We missed a space there. As our next case, and then from there, we do echo. And then we're gonna call. So this is something I missed, is that we have to do two brackets. And there we go. Then we go back and we have to do two brackets. There we go. And then we do cherry. Then we do echo. I love cherry ice cream. And then last but not least, we're going to use a wildcard to capture anything else. So we're just going to use exclamation mark, or not exclamation mark, but we're going to use the wildcard. Make sure the spacing lines up. When it comes to bash scripting, spacing is very important. And then we do echo. I don't know what that means. And then we close it. And then of course we use our two semicolons. So with that, we've now defined our case statement. So let's break this down again. First, we call case, we then call our variable, and then we call in. So it's almost like a for loop. After that, we define the different cases. The first is apple, and then you can see it echoes apple. We use the semicolon to define the case definition. After that, we get banana. Let's see, we enter banana again, and then we use the semicolons to define case definition. After that, it's cherry. Same thing as before. Then it is our wildcard to catch everything. Then we close it. Now, we should be able to run case.sh. Let's see if we type that right. As you can see, apple is quite tasty. After that, if we were to run this case.sh script, you'll see apple is quite tasty. And then if we were to go back in and do a nano case.sh and change apple to cherry, and then run this again, you'll see the output text change. So cases allow you to put in multiple conditional statements. They're an alternative to something like if then else. So if you have a if then else statement that gets very long, more than like 3 or 4 if statements, go ahead and just use a case. Let's talk about the last thing you need to know in order to write bash, and that is logical operators. So what is a logical operator? Logical operators could be considered shorthand for if-then statements. There are two types of logical operators. The first is the OR. What the OR operator does is evaluate an if-then statement, and if at least one of the conditions in that if-then statement is true, it runs. The AND logical operator evaluates an if-then statement in shorthand, but both conditions have to be true. So you can pass up to, well, not both, rather all conditions have to be. First, we go ahead and we spin up our VM. Then we're going to create a file to actually write the code in. So we're going to do touch logical.sh and then make it executable. Then after that, we're going to go ahead and actually edit the file. Cool. Of course, we start every script with the shebang bin bash. Then we comment and we'll do logical op example. Then we can actually start the code with our logical operator. First, we comment our code and we're going to call this defining bars. We're going to call this num1 equals 10, num2 equals 20. Then we do logical op text. We do if, then phi. We then do brackets, and then we define the and again, and then we do brackets. So what we just did was a logical op, and we made it an and statement. So we comment that into our code. Then from there, we can actually start defining the logic of this. So again, between the brackets is going to be spaces. And then we do num1 is greater than 5. And we go forward again. And then we do num2 is greater than 15. Then we do echo, both are true. And there we go. And then this is going to be our logical OR operator. So we do logical OR op as our comment. And it's basically the same structure. Do if, then phi. Make sure that space isn't there. Right? And then we're going to do the same thing we did before, except this time instead of using the and signs, we're going to use the or sign, which is basically the two lines. And then we do that again, and we make sure there's the proper spacing in between these brackets. And then from there, we can do stuff like num1 greater than, and then we can do num2 is greater than 15. Then we do 1, 2, 3, 4. Echo. I'm going to do at least one condition is true. And there we go. We are done. So with that, we've just defined a script. And we have two comparisons. We have a and comparison, and we have a or comparison. So number one will only run if both conditions are true, while number two will run if either one of those conditions are true. Let's do 20. So now what we can do is run logic.sh. We ran into an error. Okay. So all these other scripts, we've had no problems with them. How do you troubleshoot a script that has errors? Well, there is a command for that. Right, we actually use the bash command. We do -x for debugging, and then we point this to our script. Right, so it says in line 17 of our script we have an unexpected end of file as well as a logic error in line 17. So let's open this back up. Here we go. You use nano-l to open up nano with the line counts. And it says it was line 15 and line 17. So we had an extra space in line 17. Remove that extra space as well. And we also left this one unclosed. I see. We also forgot the $sign on line number 2. And then we close that. And then from there, we're going to do -x, and then we do /logic.sh. And as you can see, both are true. And that is how you run a logical operator. Now, what happens when we go back into that script and change the code again? So we go back in, we do num equals 20, num equals 2. We state both are true. So let's change this to 5, and let's change this to 25. There we go. So we did 4 and 25, and then we run the script again, and you'll see at least one condition is true. And that is it, boys. That is the chapter on scripting. Would you believe me if I told you the text was way shorter than this video? But actually figuring out how to explain these concepts took quite a bit of time. But if you walk through this, it's going to teach you some great concepts. Hope you have a great day.